the figure given below, the value of R is, I need to find the value of this particular resistance. This is 100 volt source. I have 10 in parallel with 10, and this voltage source delivers a current of 8 amperes. So when I see this, I can say that the resistance when I look into this circuit must be 100 divided by 8, right? It must be 100 divided by 8, which is 12.5 ohms. 100 divided by 8, which is 12.5 ohms, which means that this equivalent resistance must be 12.5. I know that. Now 10 parallel 10 is 5. I can say that if I remove this and if I take the parallel combination, that must be 5 ohms. Now R is in series with this 5, and that combination has got a resistance of 12.5, which means that value of R must be 7.5, because 7.5 plus 5 is 12.5. So the value of R must be 7.5 ohms. A 3 volt DC supply with an internal resistance of 2 ohm supplies a passive nonlinear resistance characterized by the relationship V of NL is equal to I square NL. The power dissipated in the nonlinear resistances. So what it means is that if this voltage is V, the current is I, then V is equal to I square. That is the way this particular nonlinear resistance behaves. So V is equal to I square is the relationship which holds a voltage and current through this particular nonlinear resistance. Now this is 2 ohm and this is 3 volt. So I know that if this current is I, this current will also be I, right? So this is the scenario. Now I ground it. So this potential is 3 and this potential is V according to my variable. Now I know that current flows from this point to this point, which means that the potential difference across the resistance, 2 ohm resistance, will be 3 minus V, right? It must be 3 minus V. Now that will be 2 into I, because 2 is the value of resistance, I is the current. So 2 into I according to Ohm's law, product of current and resistance must get me the potential drop. So 3 minus V is equal to 2I. I know that V is I square. So I take I square to this side, so that the equation becomes I square plus 2I minus 3 is equal to 0. I plus 3 into I minus 1 is equal to 0. So I have two solutions. One is minus 3. I cannot have a current value like that, or else I can consider it as a current flowing in this direction. But the problem here is that this is not a source. So I cannot expect current to flow in this direction. This is the source, right? So this is the only valid value for I, which is I is equal to 1. Now I know that current is 1, voltage is also 1 then. So power will be voltage into current, which is 1 watt.